Classical probability. Classical probability is the statistical concept that measures the likelihood probability of something happening. In a classic sense, it means that every statistical experiment will contain elements that are equally likely to happen, that is, equal chance occurrence of something. Therefore, the concept of a classical probability is the simplest form of probability that has equal odds of something happening. Now, let's look at some examples. Example 1. A typical example of a classical probability will be the rolling of a fair dice, because it is equally probable that top face die will be any of the 6 numbers on the die. So either 1 or 2 or 3 or 4 or 5 or 6. Is that clear? So meaning that all of them now, they have equal chances. Is that okay? They have equal chance of what? Occurrence. Equal chance of occurrence. Now, let's look at another example. Another example is tossing an unbiased coin. There is an equal probability that your toss will yield either head or tail, and nothing either the head or what? Or tail. Another example. So in selecting bingo balls, each numbered ball has an equal chance of being chosen. Is that clear? So there are still some other several examples of classical probability. So they are very simple. So other examples of a classical probability, that is drawing cards from a deck, guessing a multiple choice test, selecting jelly beans from a bag, and then choosing people for a committee, etc. etc. Now, the next thing we are going to look at now is the formula for calculating classical probability. So the formula is the number of favorable outcomes over number of possible outcomes. Number of favorable outcomes over number of possible outcomes. Now, for example, now determine the probability of getting even number when rolling a die. So when rolling a die, the number of possible outcomes will be equal to 6. Is that okay? Because the faces, they are what? 1 or 2 or 3 or 4 or 5 or 6. So if you count 1, 2, 3, 4, 5, 6, so all of them, they have equal chance of what? Occurrence. Now the number of even numbers now. So if you now come to this phases 1 to 6, so how many are even numbers? So 2, 4, and 6 are what? They are even numbers. So if you now count 1, 2, 3, so it's equal to what? 3. Now the probability of getting an even number now is just 3 divided by 6, which is equal to 1 over 2. So you can see that this one is very, very simple. That's why we say that this classical probability is the most simplest form of what? Probability. Now, let's look at another one. So, another one here. In a single throw of a fair coin, find the probability that a head appears, or B, a tail appears. So the solution, that is the number of possible outcomes. So it doesn't fair coin. So the outcomes will be head or tail. Is that okay? Then we have just two outcomes, one head or tail, which is two outcomes. So the probability of having head is just, we have just only one head here. It's just 1 all over what? Total outcomes, which is equal to 2. So 1 over 2. Also, probability is equal to 1 over 2. Exactly, is equal to 1 over 2. So now there are some instances now that this classical probability cannot work with. So classical probability cannot be used. Dividing the number of events by the number of possible events is very simplistic and isn't suited for finding probabilities for a lot of situations. For example, natural events like weight. So how can you now say that the total weight that somebody is supposed to have, something like this? So like height and test scores they need normal distribution probability charts to calculate probabilities. So in fact, most real life things are not simple events like coins, cards, or dice. So you will need some more complicated than classical probability theory to solve them. So, and this one will now lead us to another concept, which is frequential or empirical approach to probability, and that will be our next topic. So I would like you to now practice the following exercises. So define probability in your own time. Is that okay? So question number 2, Ahmed throws a dice. So find a probability that it is a 2. If it's not a 2. So Maha writes the letters of the word mathematics on separate cards. So she takes one card as random. So find the probability that the letter on the card is an M, X, or T before J in the alphabet. So that will be the, so that is that about classical probability. So